Welcome to Algebra 2, Unit 5, Lesson 2. This is going to be talking about determinants and doing starting out by doing some work by hand, and then also using the graphing calculator to get the determinants using that. So I'm going to be going through this lesson kind of quickly. So just please go ahead and pay attention and pause the video, rewind it as many times as you need until you feel comfortable doing this work. But again, this matrix work is simply requires just a little bit of practice, so make sure you guys take that time and practice on it. All right, to find the determinant of a matrix, okay, first of all, there's some symbology we need to understand. The symbol for determinant is D, or we can also write it as a DET, which is the one I typically like to use. You can say the determinant of this matrix, and we can say equals an answer. Okay, we can also use notation. Two vertical lines, okay, would also represent the symbol for the determinant. Okay. Now, doing matrices by hand can get a little bit tedious, so we've got to follow some rules. Okay, it's to find the determinant of a matrix, we go diagonal down, A times D minus diagonal up. So diagonal down, AD minus diagonal up. All right. So diagonal down, 2 times 4 is 14. It's 30. The determinant of this matrix is negative 16. Okay. It's pretty easy when you have a 2 by 2. Okay. When you have a 3 by 3 matrix, it gets a little bit tedious. So what you do is you copy the first and second row outside. Okay. Copy the first row right here, copy the second row right here. The reason we do that is so we can draw a diagonal straight down and we don't miss anything. Okay. So we draw the diagonal down. First one, 6, 1, and it hits that negative 1 outside here. Okay. We go do that. And I like to actually physically draw lines on there, just so that way I don't make mistakes. So multiply diagonal down, and this time it's the sum of all the diagonal downs. Over here, it was just one diagonal down minus one diagonal up. This time we're going to have 3 diagonal downs. So multiplying diagonal down, we get a 0, negative 6, 24, 0, negative 6, 24. We add that together, we get 18, and we multiply diagonal up. 0, negative 4, negative 90, 0, negative 4, 90. Okay, we add that up, we get 18 minus negative 94. Well, minus a minus is actually a plus, so the answer is 112. Okay. And again, I want you guys to take a moment to practice doing the determinant. Again, I just rewrote the first row outside, the second row after that. Take a moment to copy this down and then draw the lines and get the determinant for that. Right? And same thing for this right here. Okay, and again, I showed you guys how to set it up right here, and that's a negative 3, which is that negative 3 rewritten right there. Okay, take a moment to do that, pause the video, draw the lines, do the determinants for each of these, and do that. Okay, so go ahead and pause now. All right, I'm assuming you guys pause now and not just let me ramble on and just checking the answers right afterwards. The answer to this one right here is negative 57. The determinant of this one is negative 57. The determinant of this one is negative 111, and the determinant of this one is 45. So hopefully you did it right and got those answers. If not, then go back and double check your work and see if you guys ended up with that. All right, let's move on to the next page. Okay, determinants can only be found for square matrices. Square matrices are a 2 by 2, a 3 by 3, a 4 by 4, 5 by 5, and so on. Okay, determinants can be used to solve equations of finding the area of triangles. And the notation, like we said, is 2 vertical lines, or we can write the word DET and then the brackets to denote this. This is the one I like. Again, we can find the determinant by doing the diagonal method, which is the one I've just taught you, expansion by minors, and doing calculations on it. So I'm going to show you guys now the easy way. Okay, hopefully you're able to get the answers. To find the determinant of this matrix A, okay, we're going to use this graphing calculator. Now you guys have your notes. So I'm going to go ahead and label this one matrix A and show you guys how to plug this information in. So follow along as I do this, and here are the steps going down, and shows you exactly how to do it. So I've memorized the steps, which you guys will need to do for your test. So first turn this thing on, got it. Go second matrix. Okay, you got a bunch of matrices, and I'm going to go ahead and go to the edit on this one. And since I want to do enter the matrix in as A, so I go down to A right there, which is the one highlighted, and I press enter. Okay, I know this is a 3 by 3, so I go 3, enter, 3, enter. Okay, so now I've got a blank matrix full of all zeros. I'm just going to scoot this over just so I can see my matrix. Okay, and you're going to enter horizontally across. Okay, so it's 2, enter, 7, enter, 4. Okay, and it automatically goes down to the second row. 3, 6, 9, 1, 5, 2. The biggest mistake a student can make is not double checking the matrix. Make sure everything that's entered in properly is what is stated here, and that's the case. So you go second quit. Okay, now we're going to find the determinants. You go second matrix again. This time we're going to look at the math section, and the first thing is determinant. So I'm going to press enter. Now we're going to tell, well, we want to find the determinant of which matrix. So we're going to go back to the matrix section, matrix, second matrix. We want to find the determinant of matrix A, which is the one we entered. Okay. Press enter. Now it's matrix A is right there. Close that parentheses and hit enter, and you get the answer of -9. Again, if you did anything wrong and you did not end up with -9, go ahead and go through the steps again and figure it out. Okay, and want to make sure you guys go ahead and try this out on your own. So enter this one in, and I'll go through the small one with you guys really quickly. Okay, here we go. It's in the screen. Okay, clear that out. Second matrix. And I'm going to go, I went ahead and labeled this as matrix E. Okay, so you guys can go ahead and check that out. Okay. Oops, not matrix. I picked the wrong matrix. And a second, get out of there. Second matrix. Second matrix. Edit, go down to E. Okay, that's the mistake I made. Press enter. You can see that that's the matrix that's entered in right there. Okay, so I go second quit, second matrix. This time I want to do the math. I want to find the determinant, okay, and I go back and find the matrix that I want the determinant for. So second matrix, go down to letter E, select that one, and the answer is right there. Okay, go ahead and do the work for matrix F right there. Okay, and the answer for this one is 98,908. All right, so work it out and see if you end up with this answer. Those two answers right there. And you know, it's really important to get these skills down of entering the stuff in, just because we need to know how to do it. All right, next one. Right, to find the area of a triangle, end up this. Okay, we're given 3 coordinates. It's really kind of weird. Okay, we have points A, B, C, D, E, F. Okay, and we need to create, put this in a 3 by 3 matrix. Well, obviously we've only got 2 points, 2 points, and 2 points. Or 2 values, 2 values, 2 values. So we stick AB first right there at the very top, and it really doesn't matter which one you put where. But AB followed by the number 1, CD followed by the number 1, EF followed by the number 1. When we do the determinant, remember, if we multiply diagonally down, multiplying by 1 doesn't change the answer, so it's really good to put the number 1. If you put any other value in there, obviously you will change the values. Okay, and now we've got a plus or minus. Well, what's with the plus or minus 1/2? Well, if the determinant of this ends up being negative, you multiply by -1/2 to get a positive value for the area. If this determinant ends up being positive, then multiply by +1/2 to get the value of the area. The reason we give us that option is because we can never have a negative area, so we got to do it this way. So here's a quick little example. Okay? Finding the map on the southern part, the triangular part of the map of Nevada. Okay, got the coordinate 00 at Carson City, 318.0 at Humboldt in the National Forest, and the California, Nevada, Arizona border right here, -318, -258. Okay, so that's your first point, second point, third point. Okay, it's point 00, so 00. Next piece is 1. Okay, this one is 318.0 and 1, -318, -56 and 1. Okay, when we find the determinant of this guy, and you guys should practice plugging this in, you get this number right here. Okay? Because it's negative, we're going to multiply by -1/2 because we want an area that's positive. We can never have a negative area. Okay, so ends up being that. All right. Okay. You can go ahead and try this one out. Okay, we've got this points here. Okay, 2, 4, -2, 2, 3, 0. We do that, and we plug it in. 2, 4, 1, -2, -2, 1, 3, 0, 1. Make sure you have that row of 1s on the back. Okay, plug this matrix into your calculator. Find the determinant of that, and the determinant of this matrix is 22. Because that's positive, we're going to multiply by positive 1/2, and the answer is 11 for the area of that triangle. All right, multiplying matrices by hand. Okay, matrices can be multiplied if the number of columns in the first matrix equals the number of rows in the second matrix. Very important we follow this rule. Okay, the product will be the number of rows in the first matrix by the number of columns in the second matrix, the outside numbers. That's a lot of confusing stuff. Let's get a visual on this. Okay, matrix A is a 3 by 2, matrix B is a 2 by 4. So we look at it, the inside two numbers, we just draw a line between the two. Okay, if these inside two numbers are equal, well, we can multiply them. Okay, the answer is going to be a 3 by 4 matrix, the outside two numbers. So if the inside two numbers are equal, the resulting matrix will be a 3 by 4. Okay, again, let's see, can I multiply A, which is a 1 by 3, times B, which is a 3 by 1? Sure, because the 3's in the middle are equal, so the resulting matrix will be the two outside numbers, a 1 by 1. Okay, let's see if I can multiply this time. It's A is a 2 by 5, B is also a 2 by 5. Look at that. The inside two numbers are not the same, so we cannot multiply them. Okay, we can, however, add these matrices because their dimensions are identical, and these would be matrices we can add or subtract. Okay. Now, here's a missing dimensions piece right here. If the first matrix is a 3 by 5 and the resulting matrix is a 3 by 8, well, what must matrix B be? Well, in order to multiply matrices, the two inside numbers have to be the same. So the first part of matrix B has to be a 5. Okay. Now, the outside two numbers determine the resulting matrix. So we got a 3 right there. Well, the second number in the B must be an 8 because these two numbers have to be the same in order to multiply, and these two numbers create the answer. Okay, following the same thing, we end up being for A 2 by 1. Okay, these two ones are equal. Okay, and the 2 and the 6 form the 2 by 6 right there. Now, how do we actually find the product of two matrices? Well, this one's a little bit tricky. Okay, so again, first thing we need to do is determine the resulting matrix. Well, a 2 by 3, which is 2 rows by 3 columns, versus a 3 rows by 2 columns. When you multiply them, we have to double check. Okay, 3, 3. So the resulting matrix is going to be a 2 by 2. So I just created that box right there. Okay, so what you want to do is actually draw across right here to show you that the elements are split up. Okay, we have 4 elements in that. This is row 1, column 1. So we multiply row 1 of this matrix by column 1 of this matrix right here. So row 1 is 3, 1, negative 4, 3, 1, negative 4, multiply by 0, 3, 1. 0, 3, negative 1. Sorry, that's a negative 1. When you multiply those and add those together, you get the number 4. This is the first row times the second column. So first row times the second column. 3, 1, negative 1, 3, 1, negative 1 times 8, 1, 5. 8, 1, 5. Multiply and add, we get 20. Okay. Follow the same steps. Second row times the first column. Okay. Second row times the second column. And you can see the work created right there. Okay. And we end up with 22 and 18. Try this on your own and see if you guys come up with the same answer. Again, always practice everything that I'm trying to teach you guys right here on your own. Don't just copy down the notes just so you have them. All right. Okay, 2 more examples. We have a 2 by 3. Always write this down first, and a 3 by 3. Well, the resulting matrix is possible, right, because the 3's on the inside are equal, and the resulting matrix will be a 2 by 3. 2 rows by 3 columns. Again, always try drawing this as it tells you. This first number came by the first row multiplied by the first column. Okay, this one came by the first row multiplied by the second column. Okay, and this is the first row multiplied by third column. Okay, and same way it goes down here. Okay, and you end up with these. Double check your work and see if you guys get this. Again, this is a little bit tedious, so you might have to pause and just work through it. Right? Again, like I told you guys, always write down the dimensions of the matrix first and double check. Can I do this? Well, this is a 2 by 3 times a 2 by 2. Bam, well, look at that. 3 and 2 are not equal. So this is an undefined and not possible because the dimensions do not align properly. Right. Now matrices have actual real-world applications besides just annoying you guys. Okay, reading this question, we've got March, April, and girls, boys 10 speed, boys 5 speeds. These are the sales of these things respectively. Okay, we plug those in. Okay, we can write this as a 2 by 3 matrix like this, or we can write it as a 3 by 2 like this, where the bicycle styles are going across and the months are going down. Either way is acceptable, but make sure you write this down right underneath it, the dimensions. Okay, now the sales are like this. Okay, the profits are 20 for the girls 10 speeds, 20 for the boys 10 speeds, and 15 for the boys 5 speed. We can write it as one row, a 1 by 3, or a 3 by 1. Either way, the answers are correct. However, if I ask you guys to multiply them together, let's see which ones work out. These two will not work out because the inside numbers will not line up. And if I did it the other way, the 3 and the 2 would not line up, so I can't put this matrix first and this one second. Okay? Let's see if this one works. This one multiplied by this one right here. Okay? The inside two numbers do not match up. Okay? So I can't put this one first and this one second. And if I put this one first and this one second, well, that could match up. The 3 and the 3's with inside ones would match up. Okay? Or we could do it where I can multiply these two, this one first and this one second, because the inside 3's would match up. Okay, so you can multiply these two, this one first times this one, but it makes more sense to do it this way. And here we go. Okay, the resulting matrix for this would be a 2 by 1. So I write this down right here, write this matrix here, and this matrix down here, because again, the inside two numbers match up. And when I do the exact same thing, the top one would be the first row times the first column. So I take this, the 20 times the 50 plus the 45 times the 20 plus the 15 times the 30, add them all up, and we get this. Okay, this bottom one comes from the second row times the first column. 40 and 20, 50 and 20, 20 and 15. Add them up, we get this number, and that is our answer right there. Okay, last thing. Okay, let's do this using your calculators. Okay, we can plug this in as matrix A, a 3 by 3. Plug this in as matrix B, a 2 by 3. All right. And this one we can do it by hand. It's actually much faster to just do it by hand instead of plugging it in. This is a scalar multiplication. This says I'm going to multiply the number 5 into all the elements of B. So I write down B right here, and I put the 5 outside. I multiply 5 by everything inside, and we get the resulting matrix right here. Okay. Now, this one says I'm going to multiply B and times A. B times A. Well, that works out because if I put B first, that's a 2 by 3. A second, a 3 by 2. 3 by 3. And we would get this resulting matrix. However, B times A is possible, but A times B is not possible, because if I do that, look at this. If I write A first and B second, the inside two numbers do not match up, and therefore it's not possible. Okay, so we know that we know what BA is from the answer above, right here, plus B itself, and we get this answer. And if I ask you guys to find the determinant of B, you plug this into your calculator, plug B into your calculator right there, and find the determinant of it, and it says not possible. Well, why is that not possible? Going back to our first rule, the determinants can only be found for a square matrix, a 3 by 3, a 2 by 2, a 4 by 4, and so on, so it's not possible. Now in this one right here, for number 3, why is that not possible? Because, well, obviously the matrix numbers do not line up. Now, what this tells us is that there is no commutative property for multiplication in matrices. Okay, what you put first does make a difference, and what you put second does make a difference as to if we can multiply them or not. Okay, again, in number 5, why is that not possible? Because, well, it's not a square matrix. Okay, I hope this was helpful, and if you have questions, please come see me.